Good morning, good afternoon, good evening, depending on whatever time zone you guys are in. Uh, I am Shashwat. I'm a security engineer, and today we will be talking about my talk on threat modeling, Minority Report for AI Security. So, what do you like? What's Minority Report? Well, it's kind of a niche reference for whoever hasn't seen the underrated Tom Cruise movie Minority Report. You guys won't get the reference, but to put it in context for you guys, Minority Report is a movie about pre-crime, precognition, all right, where you predict the crime before it happens and you stop it from happening. So it's basically like you look into the future and you control the present. So how does that relate to cybersecurity? Well, today we're going to be talking about threat modeling and threat mapping. So I'm not going to talk about what these two things are because obviously, at this point, you guys know what it is. But if you guys know what it is, what is this talk even about? Well, that's the issue. A lot of people know what threat modeling and threat mapping is, but they don't really do it. And even if they do it, it's like, it's just a thing. There's no action taken upon it, right? So today we're going to be talking about how we can predict these threats before they happen and analyze them, map them, categorize them in like a proper way. We're going to be using MITRE Atlas for that, which is not really used a lot right now, but it should be. It's open source and it's very intensive. So yeah, let's get into it. So you can see that there's a four-stage pipeline here: predict stage, map stage, detect stage, and loop stage. So what people generally do is predict and map, and then they stop over there. They might even go, to the detect stage, but the loop stage is mostly absent. They just make a threat model, and there's some discussions about it. But once the threats are actually detected, there's no, feedback to the original threat model. It's just left there. There's no, improvement done to that, and it's just there. It's like a pointless venture. So in this talk, I'm gonna show you guys how you can create your own open source pipeline for an end-to-end threat modeling and threat mapping tool. All right. So first things first, we're going to be doing some actual threat modeling, right? For this, we're going to be using OWASP's Precogly project. It's an open source tool, and you know it's actually very comprehensive in how you can go about multiple threat modeling frameworks. There's Pasta, Linden, and you can map it to those different things and create your own threat model. So in this case, for the sake of the demo, the tools code will also be published once the doc is done. But yeah, we're going to be providing a design document, and we'll have a small little agent that reads through the document, calls OS Precogly's API, and then does the whole threat modeling generation. I will explain that in detail during the talk on how to use Precogly in an effective way to create your threat model. And once the threat model is generated, we're going to be tagging it with MITRE Atlas. All right. Each threat will be mapped to its appropriate ID in MITRE Atlas, and then we're going to have a TM bomb. So I'm pretty sure you guys know what SBOM is. So this is like an extension of that. This TM bomb will be like the shared language between, you know, the threat model and the actual implementation of your application. All right. This is what's going to be uh, a part of the feedback that's going to go into the threat model once the threats are detected. This threat model bill of materials will contain like an index of what threats could possibly occur in your application, and how you could prevent them from happening, what to do when you detect them, and so on. And so this is the predict stage, right? In my talk last year at OWASP AppSec Days, I spoke about how you can use MITRE Atlas for threat mapping, right? So that part of the pipeline is still like, it's retained over here. It's improved, in fact. We're going to be showing better attacks, and we're going to be attacking a little, RAG app live in front of the audience. We ask them how they want to attack it, just let loose over there. And if those attacks were predicted based on whatever design doc we've given for the RAG app, Then it's going to get logged on OpenSearch. It's a telemetry platform. It's going to be visualized on like our open source dashboard, and this will contain our TM bomb, which has all the you know uh, threats and then mapped atlas IDs, right? So this is the crux of it. Now you have your threats which were modeled, and these threats, once detected in your actual application, they will now get flagged and they will be fed back into your original threat model. So let's say we try prompt injection, all right? And prompt injection is detected, but it wasn't there in your threat model initially. So that means there was something wrong with how your threat modeling happened, right? So the logs from the dashboard will feed back into the threat model and say that, hey, this was not detected before. This is a problem, and this needs to be added to the threat model. So that way, your threat model is always updated with your application. And let's say an attack is successfully, detected, and then it's a positive feedback loop. It goes back to the threat model and says, hey, this is correct, this is proper. And if there's some sort of a mitigation that's done, we'll be using procedure for PI redaction. But like whatever other remediation is done, that'll also feed back into the threat model. So this will give you like a proper reference on how your threat model is up to date with what your application is, and any sort of mitigations will also affect it as well. So at this point, your threat model doesn't just become some document sitting in some Slack DM or uploaded on like a Confluence page. This is like an up to date reference of how your application is right now with respect to threats. And it makes more sense now. You have actually done threat modeling than just some document that's just lying over there, right? So yeah, this is just like an overview of what we're going to be covering in this talk. It's going to be an open source tool. uh, Everything over here is fully open source. We're going to be using OWASP's Recogly. We're going to be using MITRE Atlas and Attack, and some other tools for setting up the pipeline. Yeah, so you'll walk away with how to connect threat modeling to actual detection. That's the gap that's there now. You just do threat modeling, you do detection separately, but there's no connecting link in between, right? So you don't really know if your modeling actually worked and it's being detected later on. We'll be closing that gap. And also threat modeling can't really be done. I mean, you can do it manually, but why do it when there's AI, right? That's where OWASP Precogly's API comes in handy. And I'll be teaching you guys how to use that and tie it into your pipeline as well. And that's it. This is going to be like a very baseline code. You guys can take this, improve upon it, you know tinker with it according to whatever your application requires, your code base requires. But the goal is to make threat modeling a more uh, end-to-end process and let it actually have an impact on how your application is modeled, right? So yeah, that's about it. We'll be going into more detail and doing some live demos during the actual talk. Hope you guys like this idea, and would love to hear back from you guys. Thank you.